Alright guys, so in this video I just want to talk a little bit more about instantaneous rate of change. So let's say for example we have this function. Say we have a function goes like this, f of x, okay? And say we have this point right here. This point right here, and we can say this is just xi. Okay? So say we want to find the instantaneous rate of change at this point. So um, the way that we can do this is obviously with the limit that I gave you in that last video, limit as h approaches 0 of f of xi plus h minus f of xi all over h. But there is actually another way to do this. So if we think back to our average rate of change equation, if we had two values, say x1 and x2, then we could have f of x2 minus f of x1 over x2 minus x1, and this would be equal to our average rate of change. However, since we don't have an x2 or an x1, if we want to find the average rate of change at this point, we could change these to our xi, our point, and then change this to say a. And then we could take the limit as a approaches 0. And so what we're doing here is we are, say this is a, we are getting the average. Oops, sorry, this is wrong. We're taking it as a approaches xi. Okay, so what's happening here is this value is slowly getting closer to our xi, and we are taking that average rate of change as it approaches it. And so eventually, once a is at xi, we will just get the instantaneous rate of change because there is no difference between these two values. And additionally, we can find that the instantaneous rate of change can be represented by a tangent line to that point. And this is because this tangent line will give us our slope at that point. It kind of looks like the slope at this point that I just arbitrarily drew is 0. But say we take this point, the tangent line is going to be like this. If we were to get the slope of this tangent line, that would also be the slope of the at this point, the instantaneous rate of change.